Hello everyone and welcome back to Techmine Guru. I am your coach Supratim. Today we aren't just writing code, we are going to look inside the machine. We are tackling the invisible engine that drives every program you write, which is about memory management. If you have ever been confused about why changing a variable inside a function sometimes changes the original value and sometimes doesn't, this lecture is going to change everything for you. So let's dive into the paradox of mutable data. Let's start with a puzzle. Look at the code snippet here. We have an array ARR with a value of 10. We pass it into a function called change, which sets the 0th index to 50. Finally, we print ARR of 0 inside our main method. Now, the big question is, what will be the output? Will it be 10 or 50? So we are usually taught that variables are independent, right? That what happens inside a function stays in the function. Yet in that case, the function actually modifies our original data. Why? To understand this, we have to stop looking at the code and start looking at the memory. We need to understand the stack. So today, we are going to learn about the stack, how variables are stored inside the heap, and what is the difference between call by value and call by reference, right? So think of memory in two realms. Realm number one is the stack. So what is a stack? Imagine a stack of plates at a buffet. You can only touch the plate on top, right? This is LIFO, last in, first out. So whichever plate will go at the last, that will only come out first. So if you see, the stack is strict. It handles order, function calls, and primitive data types works in this stack only. So when a function is called, it gets pushed onto the stack, and when it returns, it is popped off. That is destroyed immediately. So let's visualize it with a trace. Look at this main method. So this main method is calling add function, right? Which is simply taking two parameters, x and y, and returning the sum of that. So when main is being called by our program, x is 10, y is 20, right? Main will call the add method in its stack, on the top of the stack. The add function will do its job of calculating x plus y and returning 30. As soon as it returns 30, it will come out. So when main calls add function, add goes on top into its own memory space. Whatever x and y exist inside add are completely blocked off from main. Once add returns 30, it is popped off and it is gone. And then comes the picture of multiply. So main will call multiply method. It will pass the two parameters in the multiply as 10 and 20. It will multiply both the parameters and it will return. As soon as it will return, it will get popped up from the stack. And this temp2 will hold now 200. And similarly, this temp1 was storing 30. Now, the control will come to main again. It will call the sub method where it will pass again 10 and 2 in the parameter, and it will do x minus y, which will return minus 10. And once it returns minus 10, the subtract function will get destroyed, and this will remove from the stack, and the control will come again to the main, right? So temp3 will have now minus 10, and then we will simply add this value, which will be 220, right? So this brings us to the epiphany. So we need to talk about the heap as well. So if the stack is your messy workspace where you do quick calculations, the heap is the warehouse of that. The heap is dynamic and large. It stores complex data, means your arrays, strings, and objects are stored here. But here is the catch. You never access the heap directly. You access it via an address only. So let's look at this diagram where int of a is equal to new int of 3. So on the left in the stack, we have a variable, right? But it does not hold the array. It just holds the reference of the array. That is address of the array, which is supposedly 4K. The address then points to the actual array sitting over in the heap. So remember this golden rule. The stack stores the address and the heap stores the actual data. So this variable is just like a pointer. So this leads us to a concept called aliasing. What happens if I say int of a is equal to new int of 3 and then int of a2 is equal to a. So I'm not creating a new array, right? I'm simply copying the reference. Now both a in the stack and a2 in the stack are present, and both point to the same exact address space, which is 4K in the heap. It's like having two remote controls for the same TV. If I change the channel using A2, the picture changes for A as well because they share the same destination. Now let's solve our problem from the beginning. When we passed our array to the change function, we passed the reference, the address. So even though change has its own address space in the stack, it reached out to the heap and modified the actual object at address 9k, right? Suppose this address was at 9k, it will change the actual object at address 9k. So when change finished and popped off the stack, the change in the heap remains the same. That is why the output was 50. But let's compare that to case 1. If I pass a simple integer a is equal to 10, the program passes the value, not the address. The function change int a gets a copy. It changes the copy to 50, but the original main variable stays 10 only, right? So here the output will be 10. So this is the difference between pass by value and pass by reference. And finally, before we go, let's look at the 2D arrays. In any programming language, a 2D array is just an array of arrays. So here int array of matrix is equal to new int of 3, 4. So your variable mat in the stack points to an array in the heap, right? And that array itself will hold referencing pointer to even more arrays. So your mat will hold the address of 3k. In 3k, it will be staying in the heap. Inside the 3k, every other block will store the referencing variable of their array. So it will store 2k, it will store 4k, and it will store 9k. So it's like chain of pointers. So to summarize everything, what we have learned today. So we have learned about the stack, how it operates in LIFO manner, how it stores only primitive and method calls. Then we learned about heap memory, where we learned that how it's like a warehouse for keeping objects, strings, and arrays, and it is accessed only via references only, and how to do pass by value and pass by reference. And if ever you want to reassign the value, you have to use the new keyword, which will create a fresh object and it will break the local links. So mastering memory is the first step to mastering efficiency. And speaking of efficiency, our next step in this journey will be sorting basics. If this video helped you visualize what's happening inside your code, please hit that like button, share it with your batchmates, and subscribe to Techmine Guru. I am Supratim, signing off for today. Till then, keep coding, keep learning, keep optimizing.